How to solve problems under enclosed angle using theta equals to tan inverse m2 minus m1 divided by 1 plus m2 multiplied by m1. And m is nothing but the gradient of any point or line given to you. Before we go in, let's learn three important notes here. Case 1. You might be given two lines. L1, example as 2x plus 3y plus 9 equals to 0, and L2 as x plus y plus 9 equals to 0. So to find the gradient of this line, always use this formula. M equals to negative a divided by b. Keep this in mind. Whereby a from the given line is the coefficient of x. We can call this 2 as a and 1 as a also here in the second line. And b is nothing but the coefficient of y, that is 3. And from this second line, the coefficient of y, 1 is also b. In case 2, you might be given one line and 2 points, i.e. 2x plus y equals to negative 3, and the point might be given to you as 2, 3, and 1, 0. So in this case, from line 1, you will use this formula, m equals to negative a divided by b, to find the gradient of this line. And from these points, you're going to use m equals to change in y divided by change in x, which is y2 minus y1 divided by x2 minus x1. And from the first point, this is x1, 3 is y1, and from the second point, 1 is x2 and 0 is y2, so you just substitute. Now keep this formula in mind. Case 3, you might be given 4 points. Let's say 2, 3, comma, 1, 0 as the first point, and the second point as 4, 5, and 0, 0. So in this case, you still use this formula. The gradient equals to change in y divided by change in x, whereby from the first point, you have your x1 and y1. And from the second point, you have x2 and y2. So now let's see some example using these three cases. Calculate the angles enclosed by the following lines. Line 1 is given as 2x plus y plus 1 equals to 0. And the second line, L2, is given as 2x minus 6y equals to 5. So now, from the first line, coefficient of x is a. And the coefficient of y, which is 1, is b. And 1 is c. Then now, let's recall our formula for finding the gradient of any straight line. This implies that m equals to negative a divided by b. And in this case, this implies that m equals to negative a is 2. So we put the negative sign, then we put 2 divided by b. And b is the coefficient of y, which is 1. Therefore, m equals to negative 2. Let's name this as m1. And from the second line, we can find m2. A is the coefficient of x, which is 2. And the coefficient of y is b, which is negative 6 as b. So now we put this into this formula. M2 equals to negative a divided by b. And a is 2. So this implies that m equals to negative 2 divided by b is negative 6. Negative can cancel negative. This implies that m equals to 2 divided by 6, which is 1 by 3. Let's name this as m2. So now we can recall the enclosed angle formula, which says theta equals to tan inverse m2 minus m1 divided by 1 plus m2 multiplied with m1. So we can now just substitute. Theta equals to tan inverse m2 is 1 divided by 3, 1 divided by 3 minus m1 is negative 2, then divided by 1 plus m2 is 1 divided by 3, then multiplied with negative 2 as m1. Theta equals to tan inverse 1 divided by 3, negative multiplied by negative is positive, then 2. Let's say divided by 1 here to take the LCM. Then divided by 1 plus 1 multiplied by negative 2 is negative 2 divided by 3. So now let's take the LCM of this numerator. We have 1 divided by 3 plus 2 divided by 1. The LCM would be 3 multiplied by 1, which is 3. Then 3 divided by 3, that is 1. Then multiplied by 1, that is 1. Plus 3 divided by 1, that is 3. Then that 3 multiplied by 2, which is 6. This gives us 7 divided by 3. So instead of all this, we can put 7 divided by 3. And now let's take the LCM of the numerator. We have 1 negative 2 divided by 3 because positive multiplied by negative is negative. Then we have a division of 1 here. The LCM would be 1 multiplied by 3, which is 3. Then 3 divided by 1, that is 3. Then 3 multiplied by 1, that is 3. Negative 3 divided by 3, that is 1. Then 1 multiplied by this 2, which is 2. And this gives us 1 divided by 3. So instead of all this, we can put 1 divided by 3. Now let's substitute. Theta equals to tan inverse 7 divided by 3. Then a long division 1 divided by 3. So now theta equals to tan inverse 7 divided by 3 will give us 2.333, then divided by 1 divided by 3, which is 0.333. So now theta would be tan inverse this value, 2.333 divided by 0.333, which is 7.006. Then now we put theta equals to tan inverse of this answer. Now theta equals to 81.87 degrees. Very simple. Calculate the angles enclosed by the line x plus 2y equals to 0 and lines joining each of the following points: -3, -4, and 3 and 8. So now let's see this solution. First, let's bring out the line given L1 as x plus 2y equals to 0. Now the coefficient of x is 1, which is A. And the coefficient of y is 2, which is B. And we know that the formula is m1 equals to -a divided by b. So we substitute these values in the formula of the gradients of this line. This implies that m1 equals to -a is 1, then b is 2. So now this is our m1. Then we can find the gradient m2 from the point given. m2 equals to, from the point given, we know that the first point we have x1 here, y1 here, and x2 in this, and y2 also. So this is change in y divided by change in x, which is y2 minus y1 divided by x2 minus x1. And this give us y2 is 8, then minus y1 is negative 4, divided by x2 is 3 minus x1 is negative 3. So therefore, m2 equals to 12 divided by 6, which is equals to 2. This is the gradient m2. Now let's recall the enclosed angle formula. We have m2 as 2 and we have m1 as negative 1 divided by 2. So theta equals to tan inverse m2 is 2 minus m1 is negative 1 divided by 2. Then the long division, 1 plus m2 is 2 into negative 1 divided by 2. This would be 2 plus 1 divided by 2 divided by 1, then positive multiplied by negative, and 2 multiplied by 1. This would give us 1 minus 2 divided by 2. So we can now take the LCM of the numerator and the denominator. So in this case, we have theta equals to tan inverse. From here, we can take the LCM as 2 plus 1 over 2. We take 2. We have a division of 1 here. 2 divided by 1, that is 2. Then that's 2 multiplied by this 2, which is 4, plus 2 divided by 2, which is 1. Then that 1 multiplied by 1, that is 1. We have 5 divided by 2. Instead of whole this, then we can use 5 divided by 2 here. 5 divided by 2. Then this long division. Then now let's take the LCM of the denominator. We have 1 minus 2 divided by 2. Then we take 2. We have a division of 1 here. 2 divided by 1, that is 2. 2 multiplied by 1, still 2, minus 2 divided by 2, that is 1. 1 multiplied by 2, that is 2. So here we have 0 divided by 2. So this is 0. So here we have a long division of 0. And we know that any number divided by 0 is undefined. So this would be 0. And theta would be 0 degrees. Calculate the angle enclosed by the points 1, 1 and 0, 0, joining the points 2, 7 and 3, 3. So let's see this solution. First, let's bring out the points out. The point 1 is given as 1, 1 and 0, 0. And the point 2 is given as 2, 7 and 3, 3. So now from the first point, this is x1 and this is y1. This is x2 and this is y2. And from the second point, this is x1 and this is y1, x2 and y2. So now, since we are given points, we are going to use m1 equals to change in y divided by change in x, which is y2 minus y1 divided by x2 minus x1. And from the first point, we know that y2 is 0, so we can substitute 0 minus y1 is 1. Then divided by x2 is 0 minus x1 is 1. Therefore, in this case, we have m1 equals to 0 minus 1, which is minus 1, divided by 0 minus 1, that is minus 1. Minus can cancel minus. Therefore, m1 equals to 1. So now then we need to go and find m2 from the second point given. m2 equals to y2 minus y1 divided by x2 minus x1. So this implies that m2 equals to y2 is given as 3 minus y1 is given as 7 minus 7 divided by x2 is given as 3, then minus into x1 is given as 2. So here we have m2 equals to 3 minus multiplied by minus, that is plus 7 divided by 3 minus 2, that is 1. Therefore, m2 equals to 3 plus 7, that is 10. So this is our m2. Then we recall the formula, which says theta equals m1 as the enclosed angle formula. So now we just substitute since we know the value of m2 and m1. Now theta equals to tan inverse. m2 is 10 minus m1 is 1 divided by 1 plus m2 is 10 multiplied by m1 is 1. This implies that theta equals to tan inverse 9 divided by 1 plus 10 times 1 is 10. This implies that theta equals to tan inverse 9 divided by 11. So we used our calculator to find out the value of tan inverse 9 divided by 11. So the angle is 7.605. Therefore, theta equals to 7.605 degrees.